Although the first sentence will be funny. So in my office I have a hovering Jew mouse. So that kind of pays attention. Well, in my office, not a former student. He's a current student, but he might as well be a former student. He doesn't show up. But anyways, he has he got me this thing that you're supposed to be able to put figurines on that hovers. It's like anti-gravity, right? And so I have my cat's favorite toy was a blue mouse with a Star of David on it. I always said she was Jewish, so that was her Jew mouse. Well, anyway, so I have it in there on this thing. Now, at first I thought that because you plug the thing in, but what it does when you have it plugged in, it shows light underneath it. So if you go to my office when the lights are off, you see like this blue light back there. That's what that is. And originally I thought it also turned on like the electromagnet or something. Not the case. That magnet's live all the time. So then so I came in on Saturday. I think there was a planned power outage on Saturday morning or Friday night, something like that. And the mouse had come down. The thing, you get it balanced, and then so during the power outage, the thing came down, which didn't make any sense to me. But then I couldn't get it rebalanced. So I use that as a prediction of the end of the world. Because clearly you can't get the Jew mouse to rebalance on the toy in your office. That must mean that the core of the Earth has stopped spinning. And you see that movie, right? The Core? Oh, that's a great movie. Yeah, so the idea is that the core of the Earth stops spinning, which means the magnetic field that protects us from solar rays or whatever is no longer there. And so we need to get to the core of the Earth to restart the core. And this dude happens to have this machine he built that he named the material called unobtainium that gets, the hotter it is and the more pressure, the stronger the metal gets. I don't know that convenient for the movie. But the movie's reasonably, it's a decent, it's not winning any awards, but, decent watch. It's not going to, won't feel like you wasted an hour and a half of your life. It was a reasonable movie. But yeah, so that's immediately what came to mind. Okay, the Jew mouse is no longer floating. The Earth's core has stopped, and we're going to get burned up by solar radiation. That's a reasonable assumption to make, right?
Okay. The thing, and that's a problem with space people, like astronauts. They get
this problem with space people.
They get really bad sunburn because there's no our atmosphere.
That's right.
All the things that happen when you're in
That's
space.
right.
It's a real thing.
Seriously. Right. But how would you know you don't go outside, or you would go into space? Does space count as outside?
I read a thing on Facebook about it. People's muscles get all messed up too, and
yeah, because you don't have gravity.
You can their heart is all messed up.
I mean, would you go to space?
No.
Oh. Oh, so, I was just going to say, this is kind of the pot calling the kettle black, but you going to space you're probably too big to go to space.
Oh, yeah.
Yeah, I doubt they could even come close to strapping me into the astronaut chairs, unless there's armrests and they can put me in two. But yeah, you're probably too big too.
Yeah.
So what I'm saying.
But it messes up your heart too. I don't get why you want to. It's your heart doesn't have two pushes.
Well, because man wants to explore. Human beings want to.
Like Africa or something. Rainforest.
So you don't think we should be going to space? It's just too risky.
Person to go to space. What do we have to gain from it?
We have a lot to gain from it.
Unmanned mission. I don't get why there has to be a man in it.
Well, because at some point, don't you imagine that we're gonna start inhabiting inhabiting the stars, having you don't think the things from Star Trek and stuff like that seem plausible?
No, their atmospheres aren't you can't live there.
Yeah, we have to beat the Soviets to whatever's next.
We are a very competitive nation.
Which is kind of funny since right now we're doing all of our launching on Soviet rockets. NASA's on pause.
Oh, yeah.
Oh, but I bet you Donald Trump will fix that. Yeah.
Make it great again.
the Trump rockets. It's going to be huge. We're going to build a wall around the moon. The funny thing is that doesn't seem like a far-fetched thing for him to say. Yeah.
slogan. That is the worst.
Which?
America great
Making
again?
America great again. Yeah.
Are you saying you don't want America?
Why is it the worst?
Because it sounds like him single-handedly is going to do it. I feel like it should be like.
But he says we're gonna make America.
It
great
doesn't
again.
say
He
we.
does.
Should have that
He
sentence,
does?
No, it doesn't. I've seen your sign.
Oh, well, whatever. So, but
I feel like if he said that, like we can make America great again.
the way he's portraying it is he's going to make America.
Him, like just by himself, without anybody else's help,
Yeah.
he's gonna do it. Like, doesn't that sound like dictator-ish?
Yeah, but and I don't disagree with you, but isn't that kind of all politicians? I mean, don't they all have their little thing about why you should elect them because they are single-handedly going to fix stuff?
I don't know. I'd rather like vote for a president that is gonna actually take your opinion into consideration.
Do you think that person exists?
So you're saying why do we even have a president then? Why
Well,
don't
I'm
we
not
just
into
vote on
politics. I'm
everything?
just saying.
Yeah, I mean,
politics
Yeah, I'm not political either. I just to me it seems like that likely doesn't exist. You kind of want it to exist, but it doesn't seem like it does.
No, probably not.
I mean, because realistically, at the end of the day, if you kind of get past all the fluff, we effectively live in a capitalist dictatorship, right? I mean, the government says what goes. We don't really get a whole lot of say. We pretend like we get say, but it is also driven by money here, so that's why it's capitalism.
So I want whoever's president to really work hard at pretending to listen to us. I'd be cool with that. Like,
Or at
really
least
make that
more
your
oblivious.
popularity, yeah.
More oblivious. I get it.
Yes.
Yeah.
I'd be
Well, but this is the very reason why communism looks good on paper, but doesn't work in practice. Because on paper, forget about the dictatorship side of things, but communism says everybody should get the same amount of money for whatever job they're doing. Everybody has different gifts and stuff like that, and painters should get the same amount of money as heart surgeons.
So everything
Okay.
should be free.
What I mean, it's not so much that everything's free; it's that you don't have this competition
Yeah.
for stuff. A janitor should get paid the same amount as a heart surgeon or something like that, where here we have this perception that a heart surgeon is a more important person than a janitor, right? Okay, well, who's going to pick up the garbage if we didn't have janitors? Heart surgeons aren't going to want to go and pick up the janitors. So the world takes all kinds, right? We need people with all sorts of different skill sets and all sorts of different tolerances to do all this stuff. So communism would say, shouldn't these people get paid the same amount of money?
Well, it's not
I'm sure I'm overly simplifying it, but just in my mind, but that doesn't work.
Skill.
Would
It's
you-
like, you don't need skill necessarily to be a janitor.
I don't know if that's
You need to
true.
be a heart surgeon.
No, I think that's a fair statement, but I do think to be a janitor, there are skills involved. We just tend to discount those.
Yeah.
Yeah, I think that's more of the thing is we deem heart surgeon skills to be more I guess what more tangible skills than the skill. I mean, I didn't even want to clean up cat barf, at my house. Yeah, but so I mean, how much skill does that take?
But also under communist rule, isn't it that you don't have anything and everything belongs to the government and they just allow you?
Probably, but isn't that kind of here too? I mean, on paper it's not, but in reality it sort of kind of is. Yeah.
Except
I mean-
for your home. You can't quarter troops.
Well, you have the have and the have-nots everywhere.
And they can take your house from you because it happened somewhere by me. They wanted to expand where the school was, and so this lady, they gave her a really good offer, and she said no, she wants to stay in her house. And so then half a year later,
Yeah, see, that's the capitalism
with
part.
an order, and they're like, you have to move it because we're building a federal.
Yeah, they still gave her the offer. They still gave her the
give
money.
a fair price, but
Right.
still,
So
you
it's like,
don't have
here's a bunch of money, take it and shut up, or don't take it and you'll take it.
They ended up giving her less because it was the fair market value. instead
Yeah,
of what they were offering.
should have taken the bribe.
Yeah.
Yeah, that's the way it works. That's America.
America.
That's America.
But also Trump's implying that America isn't great.
Ooh, I think
He's saying, let's make it great again.
so. Let's wrap this into education. So this is just from my view. So I've been teaching for 18 years. The bar in education has greatly dropped. 18 years ago, the folks we were giving computer science degrees to were more than a couple of steps above the average person we're giving computer science degrees to today. I think because schools are becoming businesses and it's all about, guarantees, get in, get out in 4 years. Tuition keeps going up, right? It becomes more of a business than about education. I've seen this happen just during the time I've been teaching. Our best students are still as good today as they were back then. It's the average student that's worse. And I don't think it's because people are innately dumber. I think there's a complacency issue maybe in the United States where, and technology has a lot to do with it, right? We become so reliant on technology that we don't have to use our own brains as much. So I think we get sort of lazy to, maybe that's where the adult coloring books comes in. Like when we need something to do. I think there's an argument where we're losing jobs overseas, specifically in technology. That's the only area I have the expertise to talk about, but and I don't necessarily feel bad about it because, I mean, if you're a business owner and you can pay somebody half the price for twice the competency in India, why wouldn't you? As opposed to keeping the jobs in America, hiring people with half the competency at twice the price. It just doesn't make any sense. But I also think that Americans, when backed up against the wall, can step up pretty quick, right? So I think that we kind of almost need that reality check. So I don't know. I might say that I don't think America's as great today as it has been in the past. I think we're in a lull.
We're worrying too much about equality, like you were saying with education, because it's like, I know at least in our high schools in Illinois, everybody, they have the No Child Left Behind thing where it's like you have to stop students basically who have already learned it, and you have to wait for the other people to catch up, so you're not allowing them to grow and learn.
Well, and then this also goes back to what we were talking about a few minutes ago as well, where it's, I think we've created this environment where everybody thinks they need to go to college, because it's a requirement. So what's happened now is the bachelor's degree has become the new high school diploma, and the master's degree has become the new bachelor's degree. And it's unfortunate because now you're paying more for a bachelor's degree than you've ever paid, and it's worth less than it's ever been worth. That shouldn't make any of you feel good, right? But what's also happening is now people aren't going to the trade schools. I mean, we need electricians, we need all these different people, but they're not doing those things until they go through normal school, go through college, let's say, and then can't get a job. Then they're going back to trade schools.
Well, part of the problem with the trade
with college debt.
Is with if you don't get into union, then you're like screwed if you go into a trade school.
Well, but you would get into the union now because there's a shortage. There's a shortage of people going into the industry. So yeah, I just think that it's we probably do kind of need a reboot. Because generally speaking, people don't come out of high school anymore saying, "Oh, I want to be an electrician." When there's so many people that we deem to be smart that if they tried to do electrical work themselves, they would probably greatly decrease their lifespan. Right? I mean, I consider myself a pretty bright person, but my wife won't let me do any electrical work. We hire a professional. They come in, they know what they're doing. So, and they charge a lot, but they're worth every penny, right? I don't want to get rushed to the emergency room. Well, maybe I do. That's more of a life experience type thing, just like the Egyptian sand pirates. It's kind of the same category. Yeah. So I think though, and I can't speak. Maybe it's probably society as a whole across everywhere, but at least I can only see it through our lens here. I think we're probably broken to an extent. And then I don't know. Was the Hillary Clinton? She wants to make America whole again. I don't know what's this. That's just the alternative banter. Yeah, politics is just funny.
And it's so much about bashing the other competitor. Like now on TV, if you ever watch it, there's so many
you don't have to be watching it to hear about the bashing.
It's like that's all it is. It's not about how good you are. It's about how bad they are.
Yeah. So we'll see what happens, but I certainly think Trump for president would be a pretty entertaining 4 years or less, depending on impeachment, that kind of stuff. But
probably scaring the tour that's out there.
Well, I mean, I think we're approaching it as a fairly logical. Yeah. Okay, well, it kind of is what it is. Generally speaking, we're kind of screwed regardless. So, yeah, I guess we'll see. Well, unless, maybe we get like David Letterman as president. He'd be as good as anybody else. Colbert, yeah. Nah, I think Colbert is too young um, and too politically minded. Yeah, I think he's going to scare us too.
What about Jimmy Fallon?
Fallon's more even, but he's still so young.
Yeah,
I mean, I think we need like burned out people. That's kind of what Reagan was. I mean, Reagan was a fairly popular president.
You need somebody who's burned out.
Well, I mean, he was even keeled, right? So I think Reagan was a fairly popular president, and it was almost because he wasn't really extreme on any sides. He was a retired actor, pretty well liked, not extremist on either side of the. So just kind of room temperature bathwater is kind of the approach. Huh? Oh yeah, he was an actor before he was president. I don't know if he remembered that towards the end of his life. He was kind of things were zigging when they were supposed to be zagging, but that's the worst way to go. Yeah, I mean, I'd much rather get electrocuted than like have your mind go, because he basically had Alzheimer's. That's not how you want to go. You don't even recognize like your kids and stuff. Terrible way to go. All right, so quiz was, how do we transition? How do we know that a tree is unbalanced? Go ahead.
Isn't it when one side is greater than one length longer than the other?
Yep. So when one side of the tree is beyond one depth larger than the other one, so two or more larger. So that's how we know it's unbalanced. That's what we've been looking at. So the homework assignment for today, we've already determined that the tree is out of balance, right? Now we're trying to determine how it's out of balance. Okay, so our homework assignment for today was to go in, I think we were doing this, we started in BST. So BST has a how are we out of balance function that takes in a char as a parameter. This was the last dude that we added to our tree, right? So we add a node or add a leaf to our tree, and then we ask the question, are we out of balance? If the answer is yes, and as long as we've kind of kept this cadence of always checking if we're out of balance after each add, then we would do what? We would say, okay, well, if we're out of balance, how are we out of balance? And we know the culprit is the last dude we added to the tree, right? He must be the problem, all right? So now we want to kind of locate where he was added in the tree and kind of where we left last time we were referring to as the last turn. So when he finally dropped into his final position, was he going to the left or to the right? Does that make sense? That's really what we're trying to figure out with that last thing. When he finally dropped into place, was he to the left or to the right? Now, as we're currently writing it, we are disconnecting the two. Now, some of you, hopefully, decided that you would modify the code as you're adding stuff to just always remember what was your last move. Throw it in a singleton, perhaps. And just saying every single time we add a node to our tree, we remember whenever it takes a step, we store in the singleton last turn. If we go left, last turn was left. We go right, last turn was right. And finally, in the end, if we determine that the last added leaf was the one that broke the balance, we can just ask the singleton, what was the last turn? Because we just remember where it plinkoed down into the tree. Does that make sense? So that would have been the easiest way to solve this problem, is always keep track of the last turn and then refer to it when we needed it. All right, so if we think about it from that perspective, now understand when we say how are we out of balance, the very first thing we're looking at is we start out of balance initial to the right. This is because remember we had like left left or left right or right right or right left, that kind of out of balance. So what we're really trying to do is figure out which side of the tree as a whole did the guy we just add go to. All right, so that's this very top part. So if we assume it went to the right and we try to prove it wrong here, where we say if val is less than or equal to this dot root dot get payload, that's a if we added it to the left, then the first part of our how is it out of balance is left. If we added it to the right, then it would have just stayed at right here. So here's our second part of this where, so we are out of balance secondarily left to right. So now we're trying to find the last turn. All right, so going down the rabbit hole we were going down last time, now that I've explained kind of the easy way of doing it, which we'll go back and do that, let's think about this approach as you would have approached it from your homework assignment. So to figure out how we're out of balance secondarily, we're going to go ahead and ask the root node, how is he out of balance secondarily? This is our transition from our BST to our binary tree, since that's what we kind of wrapped our binary tree inside of this thing called BST so that we can have a tree of trees, a binary tree of binary trees. So we'll go into binary tree and we'll look at out of balance secondarily. It's this guy right here. So we're asking, are we looking at a matching payload or are we a leaf node? All right, so we're asking, is the payload we're currently looking at, does it equal val? And is this guy a leaf node? That is, does his left tree equal null? That's for the false positives, right? That's if we, I think we had our example in our keynote last time where we added, I don't know, a couple times. So we might get a false positive right here thinking this was the last guy added, when in actuality, this was the last one added. So we're saying if this is the, if we have a match here, we can't decide that this was the last one until we then check his children. Specifically, does he have a left child? Because if we have a match, the only place that a duplicate would go is to the left, right? So we're saying, is this the value we're looking for? It is. But he has a left child, so it's not actually the value we're looking for. It just looks like the value we're looking for. So we'll follow the rabbit hole. Go down one more level. Okay. So we then ask the question, so we're ultimately planning on returning the last turn we made. How do we know what was the last turn? So this is that question. Was this the last thing we placed, or was there another guy that we placed? So since we've just, if we're inside here, if we're in this dot payload is equal to val, and the left tree is null, that means we are sitting, we are looking at the last tree added. Okay, this is the actual place. So we want to know what turn did it take to get here. All right, so for out of balance secondarily, what we can do is we can pass along last turn. All right, so if this is the case, what are we going to do? We're just going to return last turn, but now we need to figure out how do we handle that last turn. Okay, so let's take out a couple of these guys here. All right, so this is what happens if we know we're at the last thing. We're going to return the last turn we made to get here. Else, we're going to keep traversing the tree, going either left or right. So we need to decide, based on the current payload, should we go left or should we go right to find char being added? So if it's less than, if char is less than the current payload, it's going to go left. If char is greater than the current payload, it's going to go right. Make sense? All right, so else, well, we actually could have a secondary thing here. Well, we'll ask it all here. So we're going to say if this dot, well, let's say if val is less than this dot payload, that means we would have added it to the left. And that's where we would have actually added it, is to the left. So if this dot left tree is equal to null, which actually can't happen because we would have matched the payload is equal to val here. So we're This would be an impossibility. We're not wasting our time asking it. Let's go ahead and ask it, then I'll point out why it's an impossibility. So if left tree is equal to null, we'll return last turn. Else, if left tree is a real thing, that's where we would have added it. What would we do? We're going to return this dot out of balance secondarily, passing it val, and passing it left. That's the, we're going to follow the direction to the left, so we're going to let the next guys out of balance secondarily know that that's the direction we went. Make sense? All right, so that's what we do if val was less than payload. Else, if val is greater than or equal to payload, did we do less than or equal to and then greater than? Okay, so this should be less than or equal to. If it's less than or equal to payload, we go left. If it's greater than payload, we're going to go right. So we're going to say if this dot right tree is equal to null, which is also an impossibility because we would be sitting at the, we would have failed up above in the previous if statement. So now we'll say if the right tree is equal to null, then we'll go ahead and return last turn. Else, we must have a real right tree. So this dot out of balance secondarily, passing it val and passing it right. Okay, so that is our algorithm for doing this. So when we call out of balance secondarily on a particular binary tree, passing it a value and passing it the last turn that was made, okay, we need to make sure we start the ball off correctly. So when we originally call the roots node of this one, we're going to pass it an initial last turn. All right, so we'll go back and, well, let's just do that now while we're thinking about it. All right, so we need to pass this guy a second one. So we know we're out of balance. We wouldn't be in this function otherwise. We know we're out of balance either right or left initially. Now, realistically speaking, if we're out of balance, we know it's 2 levels down that we're out of balance, correct? So we know whatever we pass in here is going to get changed. So we can pass in hello world if we wanted to. All right. So, you know, if we, we could call this guy, default turn or something like that. And, we know that's going to get overwritten because we're going to have to go down at least 1 extra level. So it's either going to become a right or a left inside of our algorithm here. We're going to either call it again with a right or call it again with a left. And we just happen to know as people that because we're out of balance, and out of balance means more than 1 depth difference, we're going to get through this at least 1 time. We're going to make 1 additional call. All right, so we get inside here. We ask the question, am I looking at a matching payload? If I am, this might be the answer. Okay, and does this guy not have a left tree? Because if I am a matching payload and this guy does have a left tree, I'm not the actual payload. At that point in time, if I do match the payload and I actually don't have a left tree, which means the reality is it means I'm a leaf node. Logically, it means I could have a right child, but we know we wouldn't because of the nature of the problem we're solving. Okay? The nature of the problem is, since this is the dude that knocked us out of balance, we're a leaf node in this case. We wouldn't have a right child, but from just a Boolean logic perspective, we could. All right, so that's why we're only checking against the left tree here. So if the payloads match and I don't have a left tree, this must be the actual guy. Therefore, that's my last turn. That's the direction I went to get here last. All right. Otherwise, I'm not looking at the payload, or I am looking at the payload and this is not the answer because there was a left child. All right. So I'm in here under 2 different circumstances. I might have a payload that matches val, or I am still looking for a matching payload. In either case, I am not at the last leaf added. Regardless, I'm not at that last place for one of a couple of reasons. So I'm going to keep traversing the tree. If the value I'm looking for is less than or equal to current payload, that means it should go to the left. If I don't have a left subtree, okay, which actually this could happen. The way we've written this could happen because if we're in here, it doesn't necessarily mean the payloads match. So if I don't have a left subtree, then I'll go ahead and return the last, well, you know what? Let's think about this for a second. Well, this isn't going to be a problem either. So we're in here under two different circumstances. Either the payloads match and I'm not at the bottom of the tree, or the payloads don't match and I'm not at the bottom of the tree. In either case, I'm not at the bottom of the tree. If the current value should go to the left, this will not happen. Because I know in either case, I'm not at the bottom of the tree. That make sense? So I actually don't have to ask this question here. It will always, always, always be false. Because if I'm inside of this if, I know that there is a left subtree. Because I know I'm not at the bottom of the tree. So we can take that out. Which means all we have to do is return this left thing here. So I'll call the out of balance. Well, actually, I'm calling this dot out of balance. That's incorrect as we currently have it written. This should be this dot left tree dot out of balance secondarily. So if I know I should go to the left, let's just pass the buck to our left tree. Here's the value we're looking for, and here's the last turn I made was left. Else, similarly, if I know I'm not at the bottom of the tree, I don't have to ask, am I not at the bottom of the tree? So we can get rid of that if. We can steal this line and update it. Paste it in here, and this is this dot right tree dot out of balance secondarily, and we'll go to the right. That make sense? All right, so this guy should ultimately tell us whether or not our last turn was left or right. We're ultimately calling this from binary search tree. So here's our out of balance secondarily. And then for right now, we're just going to print this out. So we'll just say system.out.println out of balance out of balance initial, out of balance secondarily. So that's how we'll be out of balance. Okay? So let's go ahead and test this. Go back to our main activity. Here is our current tree. So our current tree, we knocked it out of balance with the couple of Z's there, right? So we're actually going to take this code out of here just for the time being. So we'll go ahead and build our tree, and then we're going to ask it how it's out of balance so we can test the various ways it's out of balance. All right, so let's go ahead and go back into our let's see, we were doing AVL trees, right? That's where we mimicked our trees off of. Oh no, we mimicked our trees off of tree traversal. All right, so here is our current tree. Now we added a couple of Z's to this, right? So we have a Z here, then a Z here, then a Z here. So our current out of balance should be right. That's out of balance version 1. should be right, because when we add a z to this guy, that's going to drop it. Well, actually, no, it'll drop it to the right-hand side. And when it's greater than, yeah, so it'll be right. Okay, so what we're going to do is we'll just go ahead and build our tree. We know we're out of balance. So we'll go ahead and let's just print out system.out.println tree.is out of balance. Out of balance. Well, let's just say out of balance. And then we'll go ahead and say tree.how are we out of balance, passing it the very last value that was added, which is going to be, we'll just arbitrarily, let's just pass it in here like this. We'll hard code it for right now. So the last dude we added was that z. Okay? So we're hoping this gives us a right. We should initially be out of balance. Well, we hope it gives us a true first. I think we tested that last time. And then it should give us, we're initially out of balance to the right, because that's where z would go. It would go to the right of the root node. And then secondarily, we're out of balance also to the right. That was the last turn we made. Okay. So let's go ahead and launch this. And what's funny, and this reminded me of it, this is the app we're working on in the 518 class. So this is a weird story. Is it normal? That's not a thing? All right, so then this will be extra weird. So I kept running into issues that my glasses would constantly be dirty because I had really long eyelashes and they were actually touching the inside of my glasses. So I decided, and my wife yelled at me after the fact, that I would take one of those power trimmers, right? The same things you like beard trimming, yeah, that. And I just basically cut my eyelashes off. I mean, they're still a little there because you can only get so close. World of difference. My glasses don't get dirty anymore. I mean, it's like night and day. And I used to have all sorts of problems where my vision would go blurry and stuff because my eyelashes were in the way, apparently. Now I barely have eyelashes. Problem solved. Well, not me. I still have little, I had really long eyelashes. Like in the past, the optometrist, when he would check my eyes, he would he would comment on how long my eyelashes were. He said, there's a lot of women that would kill for those eyelashes. Okay. So just like hair, where I want that to go away, I don't want eyelashes anymore either. I want non-problematic eyelashes. So that is weird, cutting your eyelashes. I looked online before she never actually let me do it. But when I first brought up the idea, she thought I was crazy. But then I looked online. Apparently, people do it.
People also buy gasoline online.
Have we explained that internal joke in here? All right, good. Well, look at this guy. This guy should trim those eyelashes because it's made of grass.
And that's what I thought you were going with when you first said that.
No, that's what reminded me of it when I passed this. Yeah. All right. So it's weird. Oh, good.
You do make a very good point because I have that problem too with my glasses always get dirty.
Yeah, they're just, and it's right in the center, right where your vision is, right?
You just wear contacts.
Both of you guys,
And then you don't have to cut your eyelashes.
I can't touch my eyes though.
That's what I thought at first, but after you do it enough times, you do it without thinking.
Oh no, I wouldn't have a problem doing it. I just don't think I look right without glasses. I think I have when you're a computer scientist and you're fat, you have to have the nerdy computer scientist geek look, and that requires glasses. It's a thing.
You lose character.
Yeah. Like this doesn't look right. If I had first of all, I just lost all of you. Because I grew up during the wrong time period for using computers. I grew up during the CRT monitor time period, and if you've ever seen a CRT monitor in a movie or something, you could see that line, the refresh rate. Okay, well, I mean, I used to spend when my friends were out playing or something. It was programming when I was 9. I would spend 14 hours a day programming on these monitors. So
Playing tennis.
I played tennis too.
Okay.
But yeah, so basically my focusing muscles in my eyes don't work. So I've worn trifocals since I was 18. Yes, I have crazy prescription. Yeah, so I lose almost all of you.
So we can all like leave and you
Well, no, I can see blobs,
Would you be able to-
but like,
Would you notice?
say this again.
Like, flip you off? Would you notice?
I can't tell you have fingers. Like hold up some number of fingers and let me see if I can tell. If it's, I see a blob, I think 1.
3.
3. Oh, okay. Let's go closer. You hold up some number of fingers. All right, I think that's 3.
4.
I'm not even kidding. My eyes are terrible. Right, here. I'll prove to you. Put these on real quick. Okay. You're almost gonna pass out.
Oh, that's bad.
I have to pay like the crazy expensive stuff for the high-end plastic. Because glass glasses. Anybody else want to try?
Yeah, I can't compensate for the.
That looks completely clear to me. Yeah. So.
Also with contacts, I've heard that bifocals and trifocals aren't good. Cause my parents have those.
Yeah.
And they tried those contacts and it's weird. So you have to like, there's like a certain spot in them.
Yeah. Well, plus I would be concerned. Well, I mean, I don't. The only reason I need the bifocals is because my focusing muscles don't work. So when I need to look at something closer, I just look lower on the glasses and it does the focusing for me. Because I can't do it on my own. But I'd be concerned with contacts because then when I'm in my boat flying down the lake, when the wind catches it wrong, contact's gone, right?
No.
You don't think so?
I make sure, like, when I go to Florida every year and we have boats and stuff there and we fine.
Yeah, but you don't go outside. You're like watching boats on TV. Right?
I actually go outside there. It's a sterile environment.
It's a sterile environment. It's yeah. All right, so we got a true, and then we got right, left. Oh, it would be right, left. It would be right, left, because the last Z. Okay, no, that answer is correct. The answer I gave you is wrong. So when we add a Z to this tree, because the last 3 things we added were Z's, right? So after the H, we got ZZZ. So we have this tree initially, we add a Z to this. Z should go to the right of the F, right. So the first Z goes right here, correct? Okay. Next Z drops in, right. We're on this Z, left of that Z, because it's less than or equal to. Okay. Next one, right, left, down here. So we're out of balance to the right, last turn was to the left. So this gave us the correct answer. Similarly, if we go A as our last 3 adds, that's going to go left, so that should be left for 3 A's. Everybody agree with that one? I think I got that one right. So instead of the Z's, we'll add 3 more A's. Oh, thank you. Well, I'm excited. My new fuel tank for my boat came in. Fits perfectly under the. Oh, here, let me show it to you. It'll be so exciting. This will be the easiest way to show it to you. Yeah, so I upgraded my. I'm upgrading my boat from a 6-gallon tank to a 25-gallon tank.
That's a lot of gasoline.
It's not. So, and my boat's not real big. It's like a 15-foot ski boat that I converted into a fishing boat from like 1978, but it's kind of like the the, I don't know, Bionic Man or something is very little of the 1978 boat is left except for just the outer shell. It's not the same motor or anything. And see what can I.
So did you upgrade because you wanted to be out on the water longer, or just so you didn't have to fill it up as many times?
Well, I guess kind of both. Part of the problem with a boat that old and it had a non-permanent tank is I have no idea. The only way for me to tell how full the tank is shake shake the thing and watch gasoline flutter around.
That's
Yeah.
a good idea.
Just did this to show my class. Ignore. Yeah, so this is a 25-gallon tank, fits on, and it'll actually go back farther, but this is the old tank, so you have to kind of shake it to just see how much gas is in there. But this one has an electrode, so I'll be able to run it up to a dial up front, because none of those controls work, right? So from 1978, they're all rusted out and stuff, so I just got a new thing, so I'll actually be able to tell how much fuel's in there. But what I want to do is I want to take it down into like the kind of intercoastal area in Milwaukee around the river system and park at restaurants and stuff, but I want to be able to drive it from Port Washington down there on Lake Michigan. That's going to be experiment number 1. Yeah, like first I'll take it down there just to test it out down in the area. Then I'm going to take it out onto Lake Michigan, drive along the coast, swimming distance, to see how a boat that size works in, so this is like 60 inches wide. So it's not a huge boat, 15 feet long, 60 inches wide. But, we have decks and stuff we built in this thing. And then after I survived the trip from Port Washington down to Milwaukee along the coast, the next experiment is go across Lake Michigan to
Michigan?
to Michigan.
That seems like a really bad idea.
Like why?
What if something happens to your boat and you're not at all near, like, and you're in the middle of Lake?
Well, that's why we're going to do the initial test.
Bring a flare gun.
just bring it with lots of flares.
Do you have like a lifeboat?
I have life jackets. What do you mean? My boat is a lifeboat.
But if you have like a little inflatable boat or something?
Yeah, you
I don't have room for that.
Inflatable boat.
that's my dinghy.
I'm just saying, if you're in the middle of Lake Michigan,
We have a paddle. We have one paddle.
what's that gonna?
And I have a trolling motor.
I'm saying if it's sinking and you're just sitting there in your life.
Well, I don't think it's going to sink. The boat's a pretty dry boat. I don't think that's the problem. I think the bigger problem could be that the 1980 85 horsepower motor could give out. It's been pretty reliable for me so far, but my previous motor died on me. I rebuilt it. That died. The new one, the guy sold me. He was asking $2,000 for it. He sold it for $600 on Craigslist. No gasoline, because it wasn't reliable for him. But it's been working great for me. I think we got it tuned better or something. But
Are you gonna like bring food with in case you get like stranded?
well, there's fish in there. What do I need food for? I got to bring my fishing
You have
rods.
to cook it.
I'm a fisherman. Well, yeah, they do salmon. They do sushi salmon stuff.
It's different.
How?
It's like the way it's prepared is like slightly different. You should not eat raw fish. That's bad.
All right, so left, got that one right. What do you mean you should not eat raw fish? You're saying that it's unsafe to eat raw salmon out of Lake Michigan? Is that what you're saying?
Dump our
Raw
sewage.
fish is fine.
At least Lake Michigan doesn't. At least Lake Michigan doesn't catch on fire.
Yeah, plus you get to the center of Lake Michigan. That's not like Milwaukee coast Lake Michigan.
Well, if like a lake is like slightly slanted downhill, so it's deeper. At one point, everything's gonna like roll to the middle where you're catching your fish at.
I don't know if that's how it works. Like, I think things change when it's underwater. Because it's like a really like slow gradient within the drop off, so it wouldn't roll. It's not like an even slope, right? You have like do, and then like a 200-foot drop off. What's this?
And I said you've got the waves pushing it.
Yeah, but the waves are only at the surface,
But there's still a little bit of current at the bottom, isn't there?
and not enough to, not like okay. So if you had something like bad, I don't think there's enough current at 150 feet down in Lake Michigan for a wave to impact that. I don't think that can happen. So,
probably stop talking about this. I think we're scaring everybody.
No, they both have other. Oh, he has a thing, but he has another class. All right, so we're left there, and let's see. Then we need to give ourselves a left right. So we'll add another A here. Let's see. How can we do a? How do we get a left right? B, C, D, E. I think adding an F to this. No. C, E. If we add a G, it should go here. No, because that'll be the wrong thing up there. All right, left. So we need to go left less than F or equal to F. So another D would drop it here. And then another C would drop it there. So that should be left, right. D, then C. Does it actually run? Or is it still in the process of launching? Well, it said it launched, okay. So that says left. So I added just confirm what I did here. I added a D, then I added a C. When the previous add was the H. So a D is going to go to the left here. D is going to go to the right here. D is going to go to the left here. And D is going to go to the left here. Okay, so we're currently 1 out of balance. Fine. So I added the D. Then I'm going to add a C. C is going to go to the left. C is going to go to the right. C is going to go to the left. And then remember we have our, so then C is going to go to the left. The D is down here. And then C is going to go to the, it is left. Hey. D. Hey. Well, at least the good news is this is humans breaking, not the code. The code's right currently. So. All right, how do we get a left? We might need to modify C, D, E. So I can go E. Oh, that's going to drop off of that. I think we need to build bigger gaps in. We need 2 letters to work with. The fact that we're going through a sequential alphabet doesn't give us the gap. All right, so instead of this E, F would go here, F, F. So let's put an F there instead of the E. All right, so all we did is replace the F with an E, or the E with an F. So this guy's now an F. All right, so now we can add another F, which is going to drop off of this. And then we can add another E, which will drop off of that, correct? So if this is an F, F will go to the left. Oh no. Oh yeah, this is an F, F will go to the left. If we add another, oh no, an E is going to go to the right of that. This is an F, F will go here. Oh, E would also go to the left. And then to the right of. So if this is an F, we add an F, F goes here. If this is an F, E would go here. E. Okay, we can leave that as an F. I think we mess with this one now if we go D here. That would be okay, we can go E instead of the D, so that becomes an E. F instead of the E becomes an F. Then all right, I think we need to draw this. FBG ADI F BG A D I C E H Okay, I think that. All right, so we're trying to create a left-right out of balance. So if we replace this guy with an F, so D becomes F. And then we add another F, so C becomes F. No, that's not going to do it either. There should be a game show. If we made this B a C, then we added an A here. Widen this a little bit. So we had an A here. That'll go to the left of the C. C then becomes, so now if we add a B, that, but we're not out of balance yet. I think that guy needs to become a B. No. Yeah. Let's give this a different color code here. D-I-C-E-H. So get rid of these guys. With that in mind, we can leave this as a B, right? So B stays. These should be our last several, and then add an additional B. That F was our, that F was our, what was that F? C, D, E, I, H. C, D, E, I, H. We still need the G to go to the right. F, B, A, G. So that'll be F, B, A, G. And then we can add the B to that, which should go to the left. And then B should go to the right there. Okay. I think you're right. That should give us a left, right out of balance. So for right now, these guys have been deleted. Left, right. Okay, good. There's our left, right. And then to do left, or do right, instead of the A, we would add a, what, GG? That's going to be right, left. So we'll dump the A, FBGB, FBG, okay, no second B. And then 2 extra G's. And then we're looking for the G. So this should be right, left, out of balance. Right, left, good. Okay, so we seem to be detecting the different types of out of balance. Let's go back into binary or ABL tree now. All right, so for our homework assignment, we're not going to deal with left, right, and right, left. We're only going to be dealing with the left, left, and the right, right. So notice if we have a left, right, or a right, left case, there's 2 steps to get it rebalanced. We're going to start with that intermediate step. And then next time we're going to write the left, right step. So if we have a left, left, so for right now you can assume that your tree is going to be out of balance either left, left, or right, right, and you could artificially create that situation. And those were the easy ones to make. Actually, this one wasn't too bad either until as soon as she said, let's make the tree shorter, and then we have more control over it. But remember, I don't have eyelashes, so it's a... Yeah. That makes sense, sort of.
No.
Really? Man. All right, so to rebalance when we have left, left, notice what's happened here. Think of it like just a dial. So this is what knocked us out of balance. All right, this guy right here. This is what knocked us out of balance. So this is where we had our out of balance initially left. Last turn was left. The guy right before our last turn becomes the new root node. Okay, so talking about this kind of out loud, what are we going to do? We're going to make our tree's root point here, but we need to preserve the old root. So we're going to preserve this old, well, we're looking at it as the old root, but remember we're dealing with a tree of trees. Okay, so this part right here is related to a little piece of our larger tree. So somebody points to this guy, right? Somebody points to this guy currently. So if we're at the very, very, very top of the tree, this guy might not have anybody pointing to him. But for anything below that, this guy, that is our current, quote, root of our local tree, has somebody pointing to him. We need to make the guy that points here actually point to this 4. And then we can add this guy to this tree. So the trick here is understanding how adding things to trees work. If I add this tree to this tree, that's completely oblivious to what else might be hanging off this tree. All right, so if I disconnect this tree's left node from this 4, and I've preserved access to him, I can then add this guy, this tree whose root is 5, to this tree whose root is 4, and it should just drop to the right. It should place it where it needs to go. I don't need to worry about all the stuff that might be hanging off the 5. Make sense? I can just add this. If I could disconnect this guy from the current tree, reconnecting his parent to 4, and disconnecting this guy's left node from 4, or left tree from 4, I now have this tree that's 5 loose. Okay? Now I can take that tree and I can add it to 4, the new local root. And it should just drop where it needs to go. So that's how we do a left-left rotation. This 4 becomes the new local root. Notice how 4 is up here and then 5 becomes his right child. Same thing's true for the right case. We just go the other direction. That makes sense? So for your homework assignment for Tuesday, implement rotate left-left and rotate right-right. Or you can think of it as rebalance left-left, rebalance right-right. All right, but I would say rotate. That's how I would probably name it. So rotate left-left, rotate right-right. So in order to test that, you can create an artificial out of balance like we've done today, and then get the balance back into place with those 2 functions. Make sense? All right, I will push the current code and put the assignment up. I'll see everybody on Tuesday.